Hi everyone, my name is Jack Simmons and I'm a research fellow at Laurentian University working as part of the Metal Earth project. And today I'm just going to provide an overview of a new geophysical atlas that has been developed using seismic reflection data and magnetic telluric data collected as part of the Metal Earth project. So the Metal Earth project was ultimately designed to evaluate the processes responsible for differential mineral endowment between greenstone belts or terrains with otherwise similar geology. And there was a particular emphasis on the poorly endowed Wabigoon subprovince in Western Ontario and the strongly endowed Abitibi subprovince that straddles Ontario and Quebec. And as part of this project, Metal Earth facilitated the collection of new seismic reflection data and magnetic telluric data across crustal scale faults, sub-province boundaries, and multiple world-class gold and VMS mining camps. So we're now at the synthesis stage of the Metal Earth project, where much of the data has already been collected and now requires interpretation on a regional scale. And from a geophysical perspective, such insights can really only be obtained by comparing standardized geophysical sections. And so that's what we've gone and done. We've standardized the various seismic, MT, and geological datasets, ultimately in order to facilitate comparisons between poorly and strongly endowed regions of the Superior Province. And this map here on the right basically just shows the locations of all of the Metal Earth transects. To make these geophysical sections publicly available, we've produced a geophysical atlas that's recently been published by Laurentian University in collaboration with Canadian Science Publishing. The atlas is essentially an ebook. It consists of 13 folios or chapters with 18 standardized geophysical transects, and each transect includes a transect summary, lithological and assemblage maps, a standardized and standalone seismic reflection section, a standardized and standalone MT section, and a composite seismic MT section with geological assemblage data sourced from a recent Metal Earth publication by Tausch Jorgensen on the Abitibi subprovince, and also various OGS and GSC publications. If you're looking to download the atlas, you can by going to the Canadian Science Publishing website and by clicking Books up in the top right-hand corner. You can then filter by date. So if you filter the age range to 2024-2025, the atlas will appear. If you clicked on the link to the atlas, you'll reach this landing page where you can download the entire geophysical atlas by clicking on the Get Access link. And the atlas includes background transect information, geological maps, as well as downscaled geophysical sections. You can also download just the high resolution geophysical sections by clicking on the link to the Metal Earth Hub. This is a direct download link, so if you clicked on this link, you'll immediately start downloading a PDF of all of the high resolution geophysical sections. The file size for the compilation of sections is less than 100 megabytes, so it's relatively small, but the sections can be downscaled further if so needed. If you're looking for the source data that was used to produce these geophysical sections, you can go to the Metal Earth Hub. You'll first need to go and click on the link to download data in the bottom right-hand corner. This will take you to a second page that hosts the data download links for each individual transect. We'll look at the Matheson Transect data download app as an example, but essentially every data download app is the same. So this is the landing page for the Matheson Transect data download app. The attribute table at the bottom of the page hosts information with respect to various lithological and structural observations and measurements. And all of that data, including the geophysical data, can be downloaded from the download directory at the top of the screen. If you clicked on the download directory link, you'll be taken to this page where you can download all of the geophysical data, which in this case includes gravity data, magnetic telluric data, And there's also instructions on how to download the seismic data. So, as mentioned, every transect includes a standardized and standalone seismic and MT section, such as these sections here from the Chibougamau transect up in the northeast Abitibi subprovince. Here, looking at the MT section at the bottom, the red basically represents highly conductive features, while the blue represents highly resistive features. Generally speaking, the upper crustal granite greenstone belts of the Superior Craton tend to be quite resistive features, consisting of mafic volcanics and felsic intrusions, while mineral deposits and fault zones, which often host sulfides, are often very conductive. So just keep that in mind as we go through some of these geophysical sections from the Metal Earth project. So this is an example of the composite geophysical transect from the Chibougamau traverse up in the northeast Abitibi subprovince. The seismic reflection and magnetic telluric survey was conducted along this traverse, ultimately to investigate the conductivity anomalies associated with some of the gold-endowed regional structures, as well as their relationship to copper-gold-endowed plutons. The seismic data was also collected to help resolve the geometry of the crustal scale features across the greenstone belt, in particular the dip and depth extent of the Barlow fault, which ultimately defines the boundary between the Opatica subprovince to the north and the Abitibi subprovince to the south. These sections are from the Chicopee geophysical transect, which was conducted as part of the Malartic transect, and it was designed to help resolve the structure of the major faults that define the interpreted boundary between the northern Abitibi subprovince and the southern Abitibi subprovince. Now, these sections have previously been discussed and interpreted in a paper that was published in Pre-Cambrian Research by Zhao in 2021, I think. But what's probably most notable here is that there is a shallow conductivity anomaly associated with the South Chicopee fault, as well as sediments of the Porcupine assemblage. This is the composite geophysical section from the Malartic transect, which is one of several transects that traverse the Cadillac-Larder Lake fault. This section is also quite interesting because it extends from the northern Abitibi subprovince across the southern Abitibi subprovince and extends into the metasedimentary Pontiac subprovince. And the geophysical data collected along this transect ultimately aimed to provide new insights into the structure of the Cadillac-Larder Lake fault, but also the hydrothermal footprint associated with gold mineralization at the Canadian Malartic gold mine. And as you can see in this image, there are multiple subvertical conductors that extend from the mid-crust up to the surface expression of the Cadillac-Larder Lake fault and the Canadian Malartic gold mine. The Malartic transect has also been the subject of recent mineral potential mapping using a variety of machine learning algorithms to identify the most prospective zones for orogenic gold mineralization. Interestingly, the most prospective zones for mineralization, as shown in yellow on this top map, basically coincide with subvertical conductors that again extend from the mid-crust up to the surface expression of established faults. The Rouyn-Noranda transect traverses the Rouyn-Noranda mining camp and is discussed in a paper that was published in Scientific Reports. The camp itself is quite unusual in the sense that it's polymetallic, characterized by minor synvolcanic mineralization, 19 orogenic gold deposits and 20 VMS deposits that are hosted predominantly by the lower Blake River assemblage. The camp is also host to the Horn deposit, which is an unusual VMS deposit with quite a large gold endowment. But probably what's most notable on this section is that there is a strong conductivity anomaly beneath the Granada gold mine, which is spatially associated with the Cadillac-Larder Lake fault and metasediments of the Temiskaming assemblage. The Larder Lake transect traverses the Lincoln-Nipissing Shear Zone and the gold-endowed Cadillac-Lighter Lake Fault, which is spatially associated with the Upper Canada and Kerr-Addison-Chesterfield gold mines. And one of the key goals of this transect was to compare and contrast the crustal structure and the conductivity anomalies associated with the Cadillac-Lighter Lake Fault and the poorly endowed Lincoln-Nipissing Shear Zone. The most notable feature on this section is that there is a conductivity finger that extends from the mid-crust up to the surface expression of the Cadillac-Lighter Lake Fault, as well as the Upper Canada deposit, while such anomalies don't really exist for the Lincoln-Nipissing Shear Zone. This is an example of the composite cobalt transect, which is located within the cobalt embayment of the Southern Province, and it extends predominantly across Paleoproterozoic sediments of the Huronian supergroup, which is known to host minor silver, cobalt, gold, and uranium deposits. And these sediments are interpreted to overlie Archean basement rocks of the Abitibi subprovince, which is supported by the occurrence of local inliers of volcanics associated with the Porcupine assemblage. And this area, and more broadly the Cobalt Basin, is currently the subject of a multidisciplinary study aimed at resolving the basement stratigraphy beneath the Paleoproterozoic rocks of the Huronian supergroup. The Matheson section is located east of the Timmins Porcupine Gold Camp and traverses the Porcupine-Desta Fault and the Pipestone Fault, which are locally associated with metasediments of the Porcupine assemblage, as well as the Black Fox and Taylor gold deposits. Now, these fault segments, and more broadly the Matheson area, are considered to be moderately endowed, especially in comparison to equivalent fault segments in the large Timmins Porcupine Gold Camp. Now, these sections are discussed extensively in a paper that was published in Economic Geology, but probably what's most notable is that there are conductivity fingers or anomalies beneath the Taylor and Black Fox gold deposits and the Porcupine-Desta Fault. The Crawchester and Timmins transects, which traverse the Timmins Porcupine Gold Camp, are currently the subject of Adamola's talk, which is coming up next. So I'm not going to discuss these sections, except to say that they exist within the atlas. So this is an example of the Crawchester transect, and this is an example of the Timmins transect. And again, as you can see, there is a very strong conductivity anomaly beneath the Porcupine-Desta Fault, as well as the giant Hollinger gold deposit. This is a composite section from the Swayze transect, which traverses the Swayze Greenstone Belt, which is located to the southwest of the Timmins Porcupine Gold Camp. This belt is host to a relatively small number of base metal occurrences and gold deposits, but is considered to be poorly endowed, at least with respect to the world-class Timmins Porcupine Gold Camp. Regardless, there are still prominent conductors beneath the Porcupine-Desta Fault, as well as the Joe Burke gold mine. Heading west, we're now in the Wabigoon subprovince, looking at the South Geraldton and North Geraldton geophysical transects. The South Geraldton transect actually traverses the boundary between the Quetico subprovince and the Eastern Wabigoon subprovince, and in particular the Beardmore-Geraldton belt, which is located just north of the boundary with the Quetico subprovince. It's host to a number of relatively small deposits, gold deposits, as well as multiple base and precious metal showings. And this region tends to be dominated by older metavolcanic assemblages that are somewhat comparable in age to the Picard, Deloro, and Stockton Rockmire assemblage of the Abitibi subprovince. Now, these transects ultimately provide an opportunity to evaluate the boundary between the Quetico and the Eastern Wabigoon subprovince, as well as to facilitate comparisons between the more strongly endowed regions of the Abitibi subprovince. But what's most notable on these sections is that there is a strong conductivity anomaly associated with the Paint Lake Deformation Zone, as well as the Beardmore-Geraldton Belt, which are known to host relatively small to moderate gold deposits. The Sturgeon Lake geophysical transect traverses the boundary between the Winnipeg River subprovince and the Western Wabigoon subprovince. The Western Wabigoon subprovince, at least locally along this transect, is known to host multiple small VMS deposits and occurrences, although they are considered to be relatively small, and the belt itself is poorly endowed relative to the Rouyn-Noranda mining camp in the Abitibi subprovince. This is an example of the composite section from the Red Lake geophysical transect. The Red Lake Magnetotelluric survey was ultimately designed to complement an existing lithoprobe seismic survey, which was conducted in the early 2000s, and it traverses the entirety of the English River subprovince, the Red Lake Greenstone Belt of the Uchi subprovince, and the North Caribou subprovince. Now, the Red Lake Greenstone Belt has produced upwards of 30 million ounces of gold and is one of the biggest mining camps outside of the Abitibi subprovince. And this section has been discussed in a paper that was published in Geology, but essentially the main Red Lake mining camp and to some extent the newly discovered Great Bear gold deposit coincide with vertical and discontinuous conductive anomalies that extend from the mid to lower crust up to the surface expression of gold mineralization. The Dryden transect is another example of a transect that traverses a poorly endowed greenstone belt. The metavolcanic assemblages here are generally older than those exposed in the Abitibi greenstone belt, although there is considerable overlap. And if you're interested in looking further at the geology of this transect and more broadly the greenstone belt, Rebecca Montesson has published two excellent papers in Data in Brief and Tectonophysics. Finally, we have the Rainy River transect, which traverses the Mather Basin and the Rainy River copper-gold deposit. The Rainy River deposit is located adjacent to the Quetico Deformation Zone and coincides with a moderate conductivity anomaly that extends from the mid-crust up to the surface, although the magnitude of this anomaly is much smaller than observed in the Abitibi subprovince. This is just a list of publications that discuss the Metal Earth geophysical transects, and so if you're interested in further reading, you can go and look at some of these papers. There are currently several research papers in production as part of the Metal Earth synthesis project that are using the geophysics data collected as part of the Metal Earth project to ultimately infer the processes responsible for differential mineral endowment between the Wabigoon subprovince and the Abitibi subprovince, in particular looking at the structure of the crust between these two subprovinces. And these papers will be released as part of a special volume in Economic Geology in 2027. So, in summary, we've produced an atlas of geophysical sections that is free for anyone to download and for anyone to use. So please feel free to download it and use it as you see fit. But probably the biggest takeaway from a lot of these large MT surveys is that many of the world-class gold deposits, particularly orogenic gold deposits, coincide with crustal scale faults and subvertical conductivity anomalies. So thank you all for listening, and if you have any questions, I'm happy to address them. Thank you.